1. Okay, we are official. And this is on video, right? Yes, it is. Okay. All right, just want to be sure. I did a whole lecture for the 8th graders, and it was on photo. And I got the very first photo of me bending over like this, right? And it wasn't very useful. Right? At least I could have taken a photo of my board. Okay, so we're going to continue working on the adding and subtracting positive negatives. And you'll actually find that this is going to be a chance to work on those as well. The reason adding and subtracting positives and negatives and understanding multiplying and dividing by positives and negatives is so important, it's in everything. It's the foundation of all higher level mathematics, right? So you've got to know that stuff cold. Like you don't even have to think. It's just so obvious to you. So what we're going to do today is we're going to talk about solving one-step equations. And some of you will know how to do this already, and some of you won't, and that's fine. You'll find with math, repetition is awesome. Awesome, 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 right? And it won't be too much repetition for too long. We will be leaving even maths group in the dust. I mean, what you guys learned in maths group, you're going to be moving way beyond that quite quickly. So before we begin, we should talk about a one-step equation. What is an equation, first of all? Yes. Okay. All right.
4 plus 3.
Okay. Is that an equation?
Yes. Well, no, it's not. You need to have an equal sign.
Oh, do you have to have an equal sign in an equation?
No. Well, you kind of do.
Equation. What? That sounds like something I've heard, a word I've heard before.
Yeah, but you don't need to put it there.
Equal.
Yeah.
Oh my God.
Equal.
You do have to have an equal sign in an equation.
They told you.
I knew it.
It could be
Yes.
imaginary if you wanted
Yes.
to.
This is, what is this called? What is this called?
Imagination.
This is that right there. That is called an expression, right? You are, it's just something that you can do something with, hopefully, but you can't find an answer. If I said this, -2 minus x,
Nothing could.
you can't tell me what x is. You can tell me a possibility for x, but you can't tell me for sure x is 7.
You could even give
It might be 11. It might be -2. We don't know. But as soon as I put an equal sign and have something here, I have one unknown, one equation. I can always solve for that unknown. Always, right? So,
Equal sign equals equation.
so as long as I have an equal sign like this, that is an equation. Equation equal, right? Equal, equation. Okay. So, can I erase that?
Must have.
All right. Now, when you have an equals sign, when you have an equation, there is a rule that is like the foundation of all algebra. What is it, Dee Dee?
What you do to one side, you must do to the other.
Da 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 da. Okay, and what is it called? We call that the
Golden rule of algebra.
golden rule of algebra. Okay, so I'm going to write it over here so that I have room to do stuff. Golden rule of algebra.
of the algebra.
I just
Algebra.
realized. Yeah, I do. Algebra.
Algebra? He's my cousin.
Okay, so this is the golden rule. Do unto one side of the equation. It's written in sort of biblical language, like, you know, the golden rule, you know, do unto others as you would have them do unto you. Do unto one side of an equation. Do unto one side of the equation exactly as you would do unto the other. Exactly
Mind blown.
as you would do unto the other.
Very deep.
Now I've seen it actually written differently. There's another way to describe it, which actually, in a way, says it sort of adds more to it. It says this, this is number one, that's way one. Here's another way to describe it. You can do anything you want to one side of the equation as long as you do exactly the same thing to the other side.
You left out the do.
What?
As you exactly.
As long as you do exactly the same to the other side, right?
Why do you write in all capitals?
Because if I wrote in all lowercase, we would be here till midnight. I'm very slow at writing in lowercase. And I'm actually bad at it in general. Okay, but it's just the way I do it. So that's interesting. So if I had an equation like, I don't know, 2 plus 4 equals 6. What? Is that a true equation or is that a false equation?
That is a true equation.
That's true. Okay. So this says I could do anything to one side as long as I do it to the other. All right, I'm going to add 100 to both sides. I see. 100 plus 2 is 102 plus 4, 106. 106 equals
106.
106.
Whoa.
Oh, that worked. That worked, right? All right. So 2 plus 2, 2 plus 4 equals 6. Let's try another one. Let's
58.
subtract. Let's subtract 10 from both sides. Okay. So 2 plus 4 is 6 minus 10.
Negative 4.
It's going to be negative 4
6
equals 6 minus 10. That's negative 4.
Whoa, magic.
Now this is interesting. By doing this, using the golden rule, I have changed the value of the equation. Do you see the final? This was 6 equals 6, basically. And now it's 106 equals 106. Here it's negative 4 equals negative 4. But even though I've changed the values, I haven't changed the equality. Do you see that? They're still equal, right? So I can do anything I want. So let's say I try dividing. Can I erase? Is that okay? Let's try dividing. Well, actually, let's try multiplying first. Now, let's say I want to multiply times 10. All right? Times 10. Now, I have to multiply both sides times 10. Now, a common mistake would be this.
No.
What did I do wrong?
You need to multiply. You can't.
Wait, what? Say? Who said that?
You.
Oh, yeah. Indira. Sorry.
So you can't just like add 10 to one product, you have to add it to 2 plus 4?
Right,
So you have to
exactly.
put your
So
parentheses
I'm
around
actually
4.
multiplying times the whole side, which means I have to use the distributive property. And I think Nate taught you that, right?
Yeah.
Matt did.
I remember Nat.
Nate did it.
Nate did.
I thought
Nate
Nate
did.
did. I thought I was
Nate
in
did
a
it.
class for it.
Yes,
But
he did.
when you multiply times a blob, I call this a blob, where there's more than one thing. It's actually a binomial, right?
Blob
There's
sounds
two
fun.
numbers, binomial. Bi.
Bob.
When you
Bob, Bob.
multiply a number times a binomial, you have to do it times each thing individually. So what's 10 times 2? 20. What's 10 times 4? 40 equals 6 times 10? 60. What's 20 plus 40? 60 equals 60. It works. It works. Okay, last one. 2 plus 4 equals 6. Let's say we want to divide it by 2. Okay, dividing by 2 means I have to divide everything by 2. The entire side. So I could do this, but I prefer doing it like this. Because what happens is sometimes when you do it like this, people say, oh, 2 over 2 is 1, so it's 4 equals 6. Right? No. 4 equals 3, right? No.
6 divided by.
It's like this. When you divide a whole fraction, you just put a line under each thing. Divide by 2. Divide by 2. divide by 2. A fraction is a division problem. You guys all know that? The numerator divided by the denominator, right? So we got 2 divided by 2 is 1, plus 4 divided by 2 is 2, equals 6 divided by 2 is 3. 1 plus 2 is 3, 3 equals 3, it works,
That was mystical.
right? So the golden rule of algebra works. It's awesome. And it helps you tremendously in solving equations algebraically. Make sense? All right, so now we're getting into the real meat of it. Should have started earlier again. Okay, so we got 3 types of problems. 2x equals 20. Now I know you guys, a lot of you probably immediately would say, well, 2 times what is 20? 2 times 10, right? So you would know immediately the answer is 10. But again, remember, I'm teaching you, I'm using simple problems so that you can develop a method that you can use to solve difficult problems, right? They get really messy pretty quickly, so we gotta figure this out. So there's 3 types. Can I erase this mess? Is that okay? 'Cause I just want to use my whole board now. Okay, there's one kind of a problem like that. We have another problem like this, x plus 4 equals 10. And a third problem like this, 2/5 x equals 10. Okay? So each of these, the goal is to get it. This is your goal. So this is your goal. You want it to say x equals. That's what you want to say. X equals something. Right? I don't want anything in front of the x. Okay? So what is the 2 doing to the x? In algebra, when a number is next to a variable, what operation, add, subtract, multiply, or divide, do you see? Bella. Is she right? Yes, that's right. That means 2 times x. When in algebra is a shortcut method, right? There's a lot of shortcuts that you're going to learn in algebra. And this is one of the shortcuts. Instead of writing 2 times x, you just write 2x. Whenever you don't see an operation, you can assume multiply, right? So when there's a number next to a variable, it's always multiply. What is the name? So this is a variable, right? And you guys know why? It's an x, right? It's a variable, right? It's an unknown right now. We can figure it out, but it's an unknown. What is the number in front of the x called? Well, yeah, but what is it called? It's called the you guys know this? It's called the coefficient.
Coalition.
This is called coefficient. That's the coefficient. Now, last night, this is important to understand. Last night, this x was all by itself. Because I came here late last night to make sure. When I got here this morning, somebody had multiplied that x by 2. Can you believe it? So how would I undo what they did? What's the opposite of multiply?
Divide!
So Isa, divide. So again, I'm going to use a fraction notation, and this is what I want to see on all your homework. I don't want to see just an answer. I want to see the method. You draw a line underneath the 2x, and that means divide. So if somebody came in and multiplied my x times 2, I'm now going to divide by 2. That will undo the multiply by 2. Don't you agree with me? But I've got to do, whatever I do to one side, I've got to do to the other. So now, what is 2 over 2 equal? 1. So 1x or x. 1x is the same as x. So whenever it's 1x, I prefer you just write x. Okay? Equals, what is 20 divided by 2? 10. Easy. All right, let's do 1a, 1b. We'll try one more. Okay, 5x equals 40. Okay, somebody multiplied my x by 5. I want to undo it. I'm going to divide by whatever the number is in front of the x, 5.
Divide by 98.
Right? Divide this by 5. This becomes a 1, so 1x, or x, equals 8. Right? Fist of 5. You guys all get that? Makes sense to you? Awesome. Okay, now let's move on to this one. I know you guys know the answer is 14, right?
No.
Okay, good. Right, it is not. Okay, I just want to be sure. X was all by itself last night. Ugh! I looked at all of these and X was all by itself. And somebody came in and they added 4 to my X. It was my X. You understand? It was my X. And they added 4. So I have to undo that. So what am I going to do with
When
my
it comes
X?
to math, sharing is not caring.
As soon as you tell me what I'm going to do. Okay, somebody added 4 to my X. I want to undo that. How do I undo it? Subtract 4. Subtract 4. Subtract 4 from both sides. I draw a line, and I have an X here. The 4 minus 4, that just crosses out. I don't need to write anything. And then I write my equal sign, and yes, you may. And, sorry. And then 10 minus 4 is 6.
Your X was
Piece of
6.
cake, right?
Verbalicious Blocador.
Piece of cake. So one more. X plus 40 equals 20. Somebody added 40 to my X. Aiden, help me. What would I do? Somebody added 40. I want my X all, my X was all by itself. Somebody came and added 40. So I got to do the reverse, right? Subtract 40. So whatever that sign is, I do the opposite sign underneath it. I'll do minus 40, and I have to do minus 40 here. So Aiden, help me. X is equal to, is that right? Negative 20? Okay. All right. Third one. 2/5 x equals 10. This is a fraction. Now, what is the fraction doing to the x? What operation? John.
The operation?
Yeah. What's the operation? What is 2/5 doing to x? Is it adding, subtracting, multiplying? It's multiplying. So technically, were you about to say you divide everything by 2/5?
No, I was actually going to change it to percent. I would say just divide everything.
Okay. So that's definitely another way. That's definitely another way. And it's not wrong. But that's not the way I want to teach right now. Okay? But very smart. But normally, they multiplied my x by 2/5, right? So I would normally divide by 2/5. This is not how I would normally do it. So don't write this down for a second. You divide by 2/5. But that's confusing. 2/5 divided by 2/5. 10 divided by 2/5. But remember, 2/5 divided by 2/5 is, how do you solve that again? You have to turn it into a multiplication, right? Remember this? See? So it's really the same as 2/5 times 5 halves, right? And look, the 2's cross out, the 5's cross out, it just equals 1, right? So, all right, so instead of doing divide by 2/5, I would rather immediately jump to this and multiply times the reciprocal, right? You remember, you know the word reciprocal? Does everybody know that?
Yeah.
So I'm going to multiply this times 5 over 10. I mean 5 over 2. And 10 over 1 times 5 over 2. Okay? So the 2's cross out, the 5's cross out. All I have left is an x. With me? Yes? Equals. Now, how can I simplify this first? Can I cross upstairs, downstairs, reduce?
Yeah.
Yes. So 2 goes into 2, both. 2 goes into 2 and 10. 2 goes into 2 how many times? Once. 2 goes into 10 how many times? 5. 5 times 5 is? 25. There's our answer. Right? 5 times 5 is 25. So x is equal to 25. And then when you get your answer, please put it in a box. Okay? Now, fist of 5. Do you guys get this?
Yeah. Yay.
Or a circle. Right. Or a circle.
Very much.
Awesome. Great.
Go home.
Good job, guys. We finished. Phew.
Yay.
All right.
Has homework.